Thank you guys, everyone who's joining our Introduction to k0rdent workshop. We'll be going through this webinar, and I certainly appreciate you guys taking a little bit of time out of your day to be here. You're interested in the k0rdent project, and this is going to be a hands-on workshop. So if you're working in platform engineering, DevOps, or managing internal developer platforms, this session is probably for you. This is what you're looking for. A little bit about the course and the requirements. Since this is a hands-on workshop, we'll do most of our learning through practice. No death by PowerPoint here. So in this format, we have access to a live lab environment, and each attendee has access to their own environment where they can run the commands alongside me. So to get the most out of this lab, you should be familiar with working with Kubernetes, especially from the command line using kubectl, kubecontrol. You should also be familiar with navigating the Linux file system and environment, creating files, editing files. And our lab environment is going to be a pre-provisioned Ubuntu server with a Kubernetes cluster already running on it. We use k0s for that. And we've also provided an AWS account. So your environment's already set up with AWS credentials, and you'll be able to use that for your provider backend that we'll talk about later for spinning up your own cluster. So what's on the agenda? Well, we'll dive into k0rdent and how it helps streamline multi-cluster Kubernetes operations. And by the end of this workshop, you'll have deployed a Kubernetes cluster using k0rdent. You'll learn the foundational components that make up k0rdent and how those components are used in a platform engineering workflow. And then we'll have a quick recap after a hands-on lab where you'll get to do all of these tasks yourselves if you'd like to. Of course, if you're just here for the ride and you just want to watch, that's fine as well. You'll get out of it. I'll walk through each step of the lab and you'll be able to see how it's done. So our first section, understanding k0rdent, the future of Kubernetes management. We think it's possibly that big. So what is k0rdent? The reason for k0rdent is because managing Kubernetes clusters at scale is complex. Platform teams need to handle provisioning, scaling, security, automation, observability, and for bigger enterprises especially, this is across multiple infrastructures. So k0rdent is a Kubernetes native multi-cluster management solution, and it helps platform teams automate cluster operations across AWS, Azure, OpenStack, VMware, and other infrastructures and bare metal. It provides declarative, GitOps-friendly ways to manage clusters. So if you're familiar with things like CAPI, this isn't a new concept. But with k0rdent, you can deploy and manage multiple clusters using a single declarative framework, automate reconciliation of those clusters, ensuring the clusters stay in the desired state, enforce governance and compliance, improve observability with built-in cost tracking and logging with some components we'll talk about. But at its core, k0rdent just simplifies Kubernetes fleet management. It reduces operational overhead, allowing platform teams to deliver applications rather than manage infrastructure. So we can put this in perspective with a little imagination. Imagine you're part of a platform engineering team and your organization is growing rapidly and different teams are deploying applications on Kubernetes. And challenges start to emerge. Developers need self-service access to clusters without waiting for infrastructure teams. They want to just on-demand create a cluster for some new project or new part of their business. Operations teams struggle with managing multiple Kubernetes environments at scale. You start to grow, you have multiple Kubernetes clusters, and it becomes challenging. Your team needs a centralized approach to managing Kubernetes clusters while maintaining developer agility. So balancing those two things is often very difficult. So this is where k0rdent comes in. So let's step back then, and we kind of have our scenario of why somebody might be looking for a better solution. And let's take a look at what Kubernetes or what k0rdent actually offers. So this is a architecture overview, very high level, very simplistic diagram, if you will, but it shows some of the main components that you would need to be familiar with. We can break k0rdent down into its three main parts. The first one being k0rdent Cluster Manager, abbreviated to KCM. And this is responsible for deploying and managing clusters across the different clouds. So you'll see the KCM controller here, and you'll see that it uses these cluster definitions to then sneak down here and actually provision those clusters onto infrastructure by interfacing with CAPI, the cluster API. Then we have KSM, which is Core-Dent Service Manager. And KSM manages the workloads across clusters. This is actually services that are getting deployed on top of this. This could also be add-ons to Kubernetes. For example, you have a cluster. You don't just need a cluster. Maybe you want to add in an ingress controller or some sort of custom storage interface or an additional add-on, right? Maybe you're providing Argo or Flux or any one of these add-ons to your clusters that you want to manage across a fleet of clusters. KSM helps with that. It helps deploy applications to multiple clusters using standardized configurations. And then we have Core-Dent Observability and FinOps. That's KOF. And KOF, as I pronounce it, provides insights into cluster health, performance, and cost tracking. It enables platform teams to optimize resource usage by giving you that high-level bird's eye view and enforce compliance policies by alerting and monitoring. And by combining these components, Core-Dent acts as that single control plane. So now instead of having to piece these things together yourself from scratch, pull in a little of this, duct tape a little of that, this is a unified solution of well-tested, well-integrated open source projects put together to give you a single platform to do all of these things, making operations scalable and efficient. That's the end goal. And you can see some of the open source technologies that are being used here. I'll call out, right? We've got Cappy being used here. We see Sveltos, there's Flux, different components here that we can talk about. And then, of course, in KOF, there's going to be a fleet of monitoring observability services implemented there. So why Core-Dent? Why does it matter for platform engineers and internal developer platforms? Well, because if you manage Kubernetes traditionally, individually, that is, you get inconsistent configurations across clusters, manual intervention to enforce policies and security, and operational bottlenecks when scaling. You can kind of imagine, right? If you start deploying one cluster, two clusters, three clusters, and then you at that point you start figuring out, we probably need some standard way of doing this. You start adding more and more clusters, more and more clusters. You have nice templates that are automating the provisioning of new clusters. That's all great. But what happens now to those old clusters that are using older best practices, older security models, older versions, and things start to creep out of best practice for your latest cluster versus your oldest cluster? And now they're all different, and they get kind of into this tangled web of dependencies. So that's not optimal, especially when you start scaling and then you start jumping across different infrastructures. And Core-Dent was aimed to solve these challenges by providing declarative cluster management. So you define infrastructure as code through Kubernetes manifest, through Kubernetes resources. And this makes it really repeatable, right? Each provisioning is exactly the same. But then you have automated reconciliation. So Core-Dent continuously monitors and corrects drift, ensuring that your clusters match the desired state at all times. Plus, it supports multi-cloud and hybrid support. Manage clusters across AWS, Azure, OpenStack, VMware from a single control plane. So you're not having to jump across different ways of provisioning clusters on different infrastructures. And then, of course, the built-in security and observability with KOF, policy enforcement, logging, cost insights. Package that all up, and that creates a very powerful internal developer platform experience. And that's really what it's geared at doing. So that's Core-Dent in a nutshell and a quick abbreviation, and I promised no death by PowerPoint. So really, I think what you're here for is hopefully to see Core-Dent in action, so that you can start to see, is this something that fits in our workflow? Is this something interesting that I want to start experimenting with? And this will get your foot in the door and start seeing what it's all about. So we'll jump into our first lab. So I'll sneak over here to my lab environment here. So the first thing we'll do is using k0s on our little Ubuntu node here. We'll just run this sudo k0s kubeconfig admin command to pull down or create a new kubeconfig and drop it in our user, which we're just using the Ubuntu user. We'll just drop it in our home.kubeconfig directory. That now sets us up so that we're using the correct Kubernetes cluster. When you're using Core-Dent, you need an initial Kubernetes cluster where Core-Dent is based on using Kubernetes as the control plane for everything, right? The API for everything that we're doing. So we need an initial, what we're calling our mothership cluster. This can be provisioned different ways. Obviously, k0s is a great option, but really this could be running in kind if you're doing this in a develop environment. This could be kind, this could be Minikube, whatever Kubernetes cluster you want. In our case, we have a single node K0s cluster here. And if you don't get this, if you get something like node not ready, no resources found, that just means the cluster is still coming up. So give it a time, try it again, and it'll come up. To install k 0rdent is really simple. We run this helm command, helm install KCM, and then point it to the chart, give it a version, give it a namespace, give it the option to create the namespace, and fire it off. This might take a minute or so, but this is just installing a simple helm chart and getting things working and installing basically all the components we need. What initially happens when we're working with k 0rdent is we're pulling down this chart, and it's going to set up some initial components. And then we're going to basically get Flux up and running, and Flux will reach out and pull down the other charts that it needs and all the other Helm stuff that it needs, and start actually reconciling the rest of the k 0rdent stuff. And Flux kind of finishes out the deployment internally. So we'll see this chart will install and think everything's good, but we got to wait for some services to come up in the background afterwards as things continue to progress and the automation continues to roll out in the cluster itself. So we'll see that once my Helm chart finishes. Great. So my chart deployed, that looks great. We can check on a few things. There's a few components we're going to check on, KCM being the first one. So if we do this little kubectl git pods in the KCM namespace, the KCM-system namespace, we should see a bunch of pods running here. That looks great. But there's the pods running. We can see they're still running here. That looks good. We've got KCM controller manager. We see our Helm controller. We see Valero for our backups. Our cert manager is installed. Source controller. That's all looking really good. So we're happy with that. Those are running. Everything looks good there. We can go on to checking KSM and see about KSM. Now, KSM is our k 0rdent state manager, which is responsible essentially for making sure workloads, services that you want pre-configured, pre-deployed on clusters is running. And under the hood, that's going to be using Sveltos, which is a really cool service for doing exactly that, service reconciliation. And so we've tweaked it, we've installed it, and you'll see that it's not there yet because the namespace hasn't been created. And this is what I was talking about before. The automation in the background is still running. It's still doing its thing. So give it a minute and it'll come up. At this point, though, I will pause for a second. So if you want to follow along, I would recommend getting as far as at least installing the Helm chart because it does take a few minutes. So if you want to run through step 1 and step 2 in lab 1, in challenge 1 here, that'll get you caught up with where I'm at. And I'll give this just another minute to finish waiting for that Project Sveltos namespace to come up, and then we'll confirm the final resources available as well. All right, let's see if my namespace has gotten created yet. Yes, okay. So back on my screen, you should be able to follow back along with me here. I've got our bunch still running here, one completed. That's looking really good. The last thing I'm going to check is for the actual management object to be in a ready state. So there's this new object that gets created in the KCM-system namespace called management. And if we get that, it's not ready yet. So we're just waiting for this to be ready. And so once that's ready, that means k 0rdent has checked all of its checks, has all of its services installed, everything's been configured, everything sounds right, and it gives you the thumbs up. So that's all we're waiting for, is this management object to be ready. And if we're interested, we can take a look at this object, just make that a YAML instead. And you can kind of see some of the stuff that's in here. So this is the status section. But if we look up here in our spec, we can see there's a few things here about providers that we're installing and the specific release version that we're installing. So if we were to say need to upgrade k 0rdent, this object is what we would need to edit in the future to actually upgrade k 0rdent itself. I should be ready. Oh, there we go. All right. So now I'm true at 5 minutes and 17 seconds, it looks like. So I'm true there. So in this section, we're going to configure credentials for an AWS provider. So why do we need to do this? Well, in order for k 0rdent to do anything with infrastructure, it needs to have the keys, the credentials, in order to access that infrastructure provider, in this case, AWS, and actually be able to create networks and VMs and storage and everything else it needs. Now, obviously, these are powerful. And so we don't want these to be globally accessible, right? So following the principle of least privilege, we want to restrict who can actually see the actual credentials to only the bare minimum. But we want our engineers to be able to use them to actually deploy clusters. But we don't want them to see the credentials. We just want them to be able to use the credentials, right? So that's what we're going to do in this lab. We're going to show how you can set up these credentials for a team we're calling widgets. And the widgets team is going to eventually want to deploy clusters using AWS as their provider backend. So first things we'll do is we'll create a secret. And I'll walk through this command here real quick. So we're doing a create secret. This is a Kubernetes secret, just generic. We've just chosen a name for it. You can name it whatever you want. We're calling it AWS Credentials Workshop. And then we're just passing in a few bits of data. In your environment, there's already exported AWS credentials in your environment. So we're just passing them in here through environment variables. So we have the access key ID, the secret access key. And because we're using temporary credentials in this lab that will expire, we also have to set a session token. So we can pass all that into this secret, into the KCM-system namespace. That's important. That's where these credentials should live. If it's in any other namespace, k0rdent won't be able to read the secret. So we want it in the k0rdent namespace, the KCM-system namespace. So we create that secret and we can just confirm that it created and it looks good. It's right here. Great. That's what we want to see. The next thing we want to do is we want to create what's called a cluster identity. And if you're familiar with CAPI, this might be a familiar concept to you. It's a concept that CAPI or the cluster API utilizes. But basically, the cluster identity is an object in Kubernetes that just defines the infrastructure identity for a particular provider. And so in this case, we're going to create one called the AWS cluster static identity kind. So I'll just go ahead and edit a file here, AWS cluster identity.yaml. And I like to see numbers, so I'll just do set number. And we'll paste in our object. So we've got the kind set as AWS cluster static identity. We're just picking a name for this object. Again, this can be whatever you want, as long as you keep track of what you've named things. You can change this if you want. Workshop AWS cluster identity is the name of the cluster identity we're going to be using. Notice that our reference is to the secret we just created. So we're creating this and we're saying this cluster identity points to this credential. And this is sort of that abstraction. So now this is how we get one object off of the actual credential. So now we can grant access to this cluster identity and they never see the actual credentials because the cluster identity just points to it, doesn't actually contain it. So this is sort of how we can start separating these pieces of data. One thing that is going to be required is the allowed namespaces. So when we're planning this out, we're thinking who needs access to this particular environment with these credentials. So maybe this is one of many AWS accounts, and I know who needs access to this AWS account. So in our case, it's just the widgets team. So we're just going to grant access to the widgets namespace here. And you could grant access to all namespaces. But again, following the principle of least privilege, that's not a good idea. So we'll save that. And we'll go ahead and just apply that to our cluster. Created. Great. That's what I want to see. All right. The next thing we're going to do is we're going to actually create the credential object. And we're going to create an object that grants permission for the widgets namespace to use the credential that we had created as well, or that we created earlier. So for that, we're going to create this little file called AWS credentials.yaml. And there we're going to go ahead and paste in this credential object with a capital C. This describes, again, just a name for the credential. This is an AWS cluster credential, namespace that it's going to be in originally. A little description. This is helpful for your users who are going to be using this credential, so maybe they can understand what this credential is actually pointing at. So this is credentials for the Workshop AWS cluster. Maybe you will have specific things you want your users, that will help your users identify which account this belongs to. We give it an API version. This is the same version as our cluster identity here. We point to the kind as AWS cluster static identity. That's what we just created moments ago. And we give it the name of that cluster identity that we created. So now it's mapping it to it. So we have this credential object that points to the cluster identity, and the cluster identity points to the secret, right? So there's our chain of credentials. Once we have that, we apply it to our cluster, create it, excellent. We'll create our widgets namespace because we haven't done that yet. So we need the namespace to start that team to start working in. So we'll create our namespace. But now if we look in that namespace and we say, okay, they're going to need to use this credential, can they see it? So if I look in the widgets namespace, do I have any credentials? No, I don't have any credentials there. So let's grant them access. And to do that, we will edit an object that's already been created. This is part of the Bootstrap process. It's called the access management object. There's only one of these in your cluster. You can't create more than one of these. It's always going to be named KCM. So this is the master access management object. And we'll take a look at what that looks like here. So we'll just edit this object. If we come down here to what's important, which is the spec. Right now we have an empty spec. It's not granting access to anyone to anything. So what we're going to do is we're going to use this to actually grant access to the widgets namespace. So the widgets namespace will have access to our credentials that we just created. So for that, I'm going to go ahead and just replace this spec with this spec, where we have a set of access rules that controls access for credentials objects. We specify the name of the credential we want to grant access to, the one we just created here. And then we also specify target namespaces. In this case, it's a list, and in that list is just the widgets namespace. So this is going to grant access to the AWS cluster credential from the widgets namespace. I'll save that. And now if I run that same command again, looking for credentials in the widgets namespace, I have it. As simple as that. Just by changing that access object, it has now basically copied that credential into the widgets namespace, and they can start using it for their environments. All right. So with that, I'll go ahead and move to our last challenge for us, which is to actually deploy a workload cluster, right? We've kind of done a lot of setup. We've installed k0rdent. As the lead platform engineer in our last lab, we set up the credentials. We said, okay, here are my secrets. I want to keep these secret, but I want to grant them access through these credential objects, through this cluster identity and through this credential object. So the next thing we want to do is deploy a cluster. Now in k0rdent, clusters are deployed through what are called cluster deployment objects, but these point to cluster templates. And templates basically are predetermined, pre-decided cluster configurations. And we can look at them by getting the cluster templates from the KCM-system namespace. Now here we have a few that are pre-built and pre-provided by k0rdent. What's nice about k0rdent is everything is composable. So you can bring your own templates. The same is true for service templates as is for cluster templates. We're just going to focus on cluster templates in this lab, but service templates work basically the same way. And so whenever you were talking about wanting to deploy services under these clusters as sort of beachhead services that need to be deployed before the user actually starts using the cluster, there's templates for those as well. They work very much the same way. But you see a few that we have here in our KCM namespace. We've got the adopted cluster. This is maybe a Kubernetes cluster that already exists, and you want to adopt it as part of your k0rdent environment and start managing it via k0rdent. You have an EKS template, AWS hosted. This is where the hosted means your control plane actually runs as pods in the management cluster. So the control plane is not actually creating any VMs. It's just creating pods in your management cluster as the control plane, and only the worker nodes are created in AWS. That takes a little bit more configuring. There's a few things you have to actually pre-provision in AWS for the hosted to work. So we're going to use this AWS standalone control plane 010 version. And so this is the template that we're going to actually use here. We can take a look at what that looks like if you guys are interested. I'll just take a look here. I guess I could just do that and pipe that to a YAML as well. And you'll see a few things here. You'll see a lot of variables we can pass in that are listed here under the status, the chart ref here. We're actually just pulling this down. This is essentially just a Helm chart that's part of the k0rdent catalog. And you can pull that down if you're take a look at it through the catalog, which I can link to later. But it's very simple. It just points to a particular chart, and then we can see some of the config of that chart that we could override in our cluster deployment. We can see AWS cluster static identity is the cluster identity that it's going to require, but we'll be able to pass in a name. There's some default cluster networks that are being decided, instance profiles that are going to get applied, etc. Now, these instance profiles have been already created for us. This is part of bootstrapping in AWS. We're not going to get into that. It's just another step. The easiest thing to do is download the little CLI tool, and it'll pre-set up all these IAM permissions in your AWS account for you. You can see that on the k0rdent docs. There's a little AWS quick start. It'll walk you through that. It's a couple commands, and it pre-deploys all the AWS credentials for you in your environment. Or sorry, all the IAM policies and profiles that you would need. But you can see, some default root volume sizes, et cetera, are just all contained in this template. So let's get through and actually create something useful here. So the widgets team's going in now, and they're saying we want a new cluster. So let's assume we've created them their own user who has access to the widgets namespace, and we've granted them the RBAC roles, which k0rdent comes pre-populated with, so that you can assign certain roles to people who need certain access. So this would be like a namespace user, for example. So here we'll go ahead and just edit this cluster template chain.yaml, and we will paste into there our cluster template chain. What this is doing is this is granting access to a particular template. So this template chain is an easy way to sort of allow a series of templates to be used in a particular namespace. We'll show you how you're going to grant access later. But for now, this cluster template chain can also not only list a set of supported templates, but also upgrade paths. So that's why this object exists, is so that you can say, okay, I've got 0.1.0, but when you create a new version, 0.2.0 or 0.1.1, you can set that as an upgrade available option here, which will mean that the user can in-place upgrade from one version to another, and they'll see that as a selectable upgrade. And if they change their cluster deployment to that new version, it will allow it, and it will do the in-place upgrade. And so you can control even the upgrade characteristics of these templates through these template chains that literally just chain one template to another. So we'll create this simple template chain here, apply that. And now we can go back and edit that same resource, that access management resource that we edited before. And this time, I'm just going to create a new line right under access rules. And I'm just going to paste in this new section here, which is this cluster template chain. So you'll see under access rules, we have a list of objects. This can be cluster template chain, credentials, and service template chains, which we aren't going to demonstrate here, but again, works the same way as cluster template chains. So we just created that new one called AWS, and we're going to grant it access from the widgets namespace. Save that. Oh, looks like I've got an indentation error here. Let's see, where's the error? This guy. So if you paste it in there, it looks like there might have been a, just make sure it lines up here. Oh, still don't have it. YAML is fun in this way. Let's see. All right. This guy needs to be 2 spaces. Whoops. This guy's here, which means this guy needs to come in. Okay, so we might have to finagle this just a little bit to make it match this one. So let's just, if you want to use this one as a template and make this one match that one, it looks like there's some indentation getting copied from the box that shouldn't be. There we go. And now we've got a valid KCM access management object. And now from the widgets namespace, we can see that new template is there. So we can use this cluster template. We've been granted access. So now the widgets environment is ready to go. So let's create a new AWS Kubernetes, an AWS-based Kubernetes cluster. So we create this cluster here. This creates a new object called a cluster deployment. And if you're familiar with Kubernetes, you're familiar with deployments in general. And a cluster deployment works very similar. It's there to control the lifecycle of a cluster. So we give it a name. We put it in our widgets namespace. We specify which cluster template we want to base this on. We specify which credentials we're going to use. These were the cluster we just got granted access to. This is the credential that we were granted access to. If you wanted to, you could turn dry run to true just to validate that this cluster deployment would actually be accepted by k0rdent and that it would work. If you turn that to true, it won't actually deploy anything. It'll just say, yes, I could do this if you want me to. I have access to these credentials. I have access to this template. This template is valid, etc. So you could do that if you were kind of taking a safe approach. We're going to roll the dice and just turn dry run to false so that it just deploys it. In our config, so this config will go into the template and pass in parameters, right? So we want US East. We're gonna set the instance type for the control plane, and we're going to set the instance type for the worker node. And of course, we saw in that when I looked at the template before, you saw some of the additional parameters that we could specify as well. We're just going to leave those default. And so by default, it's going to sort of infer a lot of these things. In this case, I believe it's using the AWS Linux and things like that for the nodes, et cetera, et cetera. So there's a lot of defaults that are set up in there. But we'll just keep it simple for this demonstration. Save that, and we'll start applying our cluster. All right, it's created, it's done. Now, obviously, we have to wait for it to reconcile. It's going to now start creating different objects in our namespace. For example, we now have this cluster deployment object that we just created. It's waiting for the control plane provider to indicate the control plane has initialized. It's waiting for a bunch of replicas to come up. So it's going to be in a false state for a while. But we also now have this new object called cluster. So if we do this get cluster in the widgets namespace, we'll see we have the widgets cluster and it's in a provisioning state. And we can get more information by looking at the status messages in here. So we'll scroll up and we'll look at the status message of this object. It's waiting on a machine deployment object, and it's waiting on workers to be available and the control plane to be available and infrastructure to be ready. 3 of 8 completed there, so that's good. Looks like progress to me. Let's check on this machine deployment, for instance. Maybe we get curious, right? So we could say, let's see how that's going. CTL-in widgets. Let's just get machine deployments. Oops, did not mean to paste that. Let's just get machine deployments. So we see we have a machine deployment for our widgets cluster machine. 2 unavailable. It is scaling up. Let's get the YAML from that to see if there's any status messages there. Yes, it's failing to perform pre-flight checks. So because I've run this lab a few times, I think this is stuck at the moment. So let's check. I'll show you some troubleshooting here. So if I jump into the KCM-system namespace here, and I get pods, you'll see there's a few controllers here. One of them is called cap-A controller. This one is for the cluster API AWS provider. So this is the controller that does all of our API calls for AWS and actually controls the infrastructure for AWS when we need it to. Very useful to know that, because now I can go ahead and do a logs on that pod and see if I see what I think I'm going to see here. Nope, looks like it's going good. Okay. So in some of these labs, the temporary credentials expire and you have to refresh them. So you'll see that in your lab notes, the steps to refresh those credentials. You basically just have to recreate the secret in the KCM system namespace. There's a little function we've created called refresh AWS credentials. Just put it here. That will actually just refresh your environment variables, which will make recreating that secret easier. But this looks like it's going good, actually. I don't see it was able to make API calls, so I think it's good. So we'll just go back and we'll just check. See, it's scaling. Okay, very good. So it is working. It's doing fine. So we'll go back and we'll get the cluster here. Looks like we have more messages. It's looking good so far. Let's take a look back here at our cluster object. Oops, that's the wrong. We want to get cluster deployment. So here's our cluster object. So it's waiting for the config map to show up. Like helm installed. So we can see some status messages here are very useful. Some annotations here that describe our cluster, but everything else seems to be progressing. So now it's just a matter of waiting for it to actually finish. I can also just check on the actual machine object, because a machine deployment is a group of machines. The machine object is each individual machine. Seeing machines here are good. They even have IDs from AWS, so that means they are getting created. And we're just waiting on the bootstrap. So what's happening now is k0rdent in the background, which is another open source tool that's a part of k0rdent, is actually doing the bootstrapping. Once the machines are provisioned, it's installing Kubernetes, installing and joining them to their clusters, bootstrapping the control plane with the configuration, etc. And my cluster is ready. So at this point, my cluster is ready. So I'll get that nice little ready message here for my cluster deployment object, which means I can go on to step 7 and I can actually get my kubeconfig credentials. So, right, the widgets team wanted a cluster. We've just spun them up a cluster. Now I need to hand over the keys so they can actually use that cluster. So I'll just use this kubectl command. But basically, you'll notice that there is a secret in the widgets namespace called widgets cluster kubeconfig. And that secret contains the base64 encoded kubeconfig that we want. So we can just redirect that, decode it, and put that into a file. And that's what we're doing with this command here. So we're just using the widgets kubeconfig as the file for our new cluster, which means once I grab that, I can specify that file as my new kubeconfig, do a git nodes, and I can see I have a full cluster, Kubernetes 1.31, 3 control planes, 2 worker nodes, up and running in a ready state, ready to go. And I can now template that over and over again. If the widgets cluster wanted another one, I would just copy that one file, that widgets cluster deployment, make another cluster deployment, and off we go. I can have another identical cluster up and ready and reconciled. If I edit that cluster deployment, again, if that template chain allows for a new template to be used, if I wanted to add a service to it by adding a service template to that cluster deployment, I would just add a service and it would deploy that service to that cluster, et cetera, et cetera. So this is how k0rdent under the hood is helping to make these things policy driven. Again, we have templates of predefined clusters. These are accepted by our organization. We want you to use these. Maybe you can have different templates for different teams, different projects, whatever it may be for your particular use case. Grant access to those templates, including service templates, not just cluster templates. Make platform management far easier. So hopefully this has been a good experience for you so far and a nice lab. All right, at this point, because I've only got a few more minutes before our workshop is supposed to end, I'm going to jump back to our slides. So what did we do? Well, we learned that k0rdent is powerful, right? It combines several open source technologies into a cohesive platform. Kubernetes native multi-cluster management. That's what it's there for. That's the tool that it is primarily for. And it's a great composable stack of well-integrated and well-tested services and software. We explored its key components, the KCM for the cluster manager, the KSM for the service manager, and we talked about the KOF for the observability and FinOps. To install KOF is just a separate workflow. You just install it on top of your cluster. That's a whole nother lab though. So we'll talk about that probably in another session, but you would install it just as simply with basically a Helm template or a Helm chart like we did KCM here and KSM. And by using k0rdent, we saw that platform teams can automate cluster provisioning, enforce consistency through these templates, reduce overhead through GitOps automation because you can actually keep these templates in remote sources. As we saw with that one template, it was actually referencing a Helm chart for the AWS template. And so you can keep those in remote sources, allowing for this GitOps flow and automation. Scale it infrastructure efficiently across cloud and on-prem environments, as again, it supports various infrastructure provider backends. So wherever your needs are, k0rdent can go there, right? So it's sort of the platform for anywhere. So that's the end of our presentation as we've prepared it. Hopefully the workshop was useful and informational to you. But with that, I'll leave you guys to the labs. Hopefully you enjoyed that. Give me some feedback if you will. And with that, I'll kind of just mute myself, turn my camera off, disappear in the background. And yeah, again, thank you very much.